Module 2 consists of two parts: a review of factoring techniques and a review of more advanced rational expressions. Let's begin with the summary of basic factoring techniques. The simplest is taking out the GCF, or the greatest common factor. This is actually the first step in any factoring problem. The greatest common factor of the constants and the variable part of the terms. So the GCF here will have to be 4, because that's the highest factor common to 8 and 20, and b squared, the smaller of b cubed and b squared. So we pull it out. 4 into 20 is 5. B squared into b cubed is b. So that's what's left of the first term. 4 into minus 8 is minus 2, and b squared into b squared is 1. On the other hand, here, constants 7 and 3 have nothing in common except 1. So the only thing common between these two terms is u minus 2. So we pull it out. We're left with just 7u in the first term and just 3 in the second term. Done. Another technique is called factoring by grouping. Work on the first two terms and the last two terms by applying GCF factoring on those two pairs. So in the first pair, there's nothing common between 4 and 5, and only u squared is common. So u squared into u cubed is just u. U squared into u squared is 1, so I'm left with 4u plus 5. In the next pair, 24u plus 30. 24 and 30 has GCF 6. That's the highest factor that divides both 24 and 30. 6 into 24 is 4, so 4u is left first term. 6 into 30 is 5. So we did GCF factoring on the first pair and on the second pair. So we see now that 4u plus 5 is common. So this is another application. We take it out, and what's left is u squared plus 6. Next, the AC method. A is for the leading term, case 3. That one. And C is the constant. AC is their product, which is 45. What do we do with 45? We list all its factors. One is a factor, the other 45. 2 cannot factor because 45 is even, but 3 is. So it's 3 and 50. 4 is not a factor, but 5 is, so the other one will be 9. We can stop right here. We don't need to, because the test is square root of 45. This is less than square root of calculator. You can see that this is less than 7. You stop at 6. 7. So now we'll look at this middle term, where a combination that will add up is 4. So we rewrite it as 3z squared plus 9z plus 5z plus 15. And do factoring by grouping. So common is 3z. 3 into 9 is 3. Z into z is 1. Common in the last two is 5. 5 into 15 is 3. So now we see that z plus 3 is common. So I take it out and be left with 3z in the first and 5 in the second. So that's it. And you can check by foiling. Z plus 3, 3z plus 5. Z times 3z is 3z is 15 plus 5z, which is what we got in the beginning. So that. Now let's take a look at that same problem, but solve it using trial and error. So in trial and error, we just guess what the factors are. There's only one way to factor 3, and that's 3 times 1. 15 is 15 times 1 and 5 times 3. Choice but to put 3z here and z there. Now for 15, we can try, let's say we try 15 and 1. We will not put 15 here because 15 and 3 have 3 in common on the other side. Now because the last term is positive, this has to be of the same sign. Positive, positive, or negative, negative. The middle term is positive, so we have to choose the positive, positive combination. Now let's try to get the middle term here. It's 1 times z and 3z times 15. So that's z plus 45z. Too big. We want only 14. So that didn't work. Again. This has to be plus and that has to be plus as explained earlier. Now we're looking at 5, 3. I cannot put 3 here because they have something in common, the 3 and the 3. So I have 5 here and that's going to FOIL. That's turned out to be correct. Next is the square of a binomial. The formula is a plus b squared is a squared, ab double. So it's the square of the first term, square of the second term, product of those two terms, double it. A minus b squared is a squared minus 2ab plus b squared. So by inspection, you can see that here the a is 1, a squared, and this is the a, the b is the 5, and the 10 is 5x double. So we see that this is really x minus 5 by inspection. Another formula that you should know is the difference of two squares. It is equal to, so over here, we can re-express this as 2x squared, 4x squared, right? And 5 squared. So x minus 5, the difference of the base, 2x. Now you can combine the methods. For example, sorry, that was actually b to the, problem is 16 b to the 4 minus 81. So I can express this as 4b squared minus 9 squared. That's a difference of two squares. So I subtract the bases and add the bases and multiply them together. However, I'm not done yet because the first factor is actually another difference of two squares, namely 2b minus 3 squared. And that gives me, I'll put it here, minus 3 2b plus 3b squared. You can apply the GCF factoring. 6, 3 divides 6, 33, and 18. Now, for the variables, there's only one variable w. So, the GCF is 3w to the 5, which gives us 3 into 6 is 2, w into 5, w5 into w7 is just, which is 7 minus 5. 3 into 33 is 11, w5 into w6 is w. 3 into minus 18 is minus 6. So now we have these two factors, factor either by trial and error or by the AC method. I'll use the trial and error. Only one way to factor 2, and it's 2 times 1. 6 is 6 times 1 and 3 times 2. I have no choice. I have to use 2w and w. Next, 6. Let's try 6 times 1. I cannot put 6 here because 2 and 6 have something in common. Okay, the sign of let me erase this one first. The sign of the last term is negative, so that means one is positive, the other is negative, or vice versa. Okay, so let's test this. The middle term is W, this, and minus 12. Oh, we got lucky. We got lucky